I'm Ryan Bierer with Bierer Meters, field operations representative. So I travel around any type of customer service needs, training on our parts, tools, anything like that. I'm available.
I'm Brent Jeffries, VP of Field Operations and Safety Trainer for Bierer Meters. And we're going to go ahead and deliver today what we call a lineman safety and tool training. First of all, Bierer Meters is owned by Walter Bierer, my stepdad. And I call him my dad. He raised me since I was a little lad. And he's been in business for 35 years now. And as you all know, we manufacture phasing tools, voltage indicators, test equipment, service testers, grounding clamps, cables, ferrules, so assemblies. So we do all these things for the last 35 years. And about 7 years ago, I started with the company and going around with this trailer right here, showing folks our tools. And about 2 years into it, I started hearing about a lot of incidences, a lot of folks getting hurt, linemen getting hurt, losing fingers, hands, legs, arms, and death. And so I told the folks 5 years ago, I said, hey, what we're gonna do is we're gonna start traveling around the country. I'll do it. And we're gonna do what we call lineman safety and tool training. So we're just gonna use our tools since we make the tools, but we're gonna focus on safety. And that's what you guys are gonna see today. You're gonna get a taste of what we do around the country. Bierer Meters, we use our extra profits and we pay for this. It's all free. There's no cost at all associated to this presentation when we travel around the United States. So anyways, last year I came to the realization that the linemen need the safety and the tool training that we bring to them, but we can't reach everyone. It's impossible. We cannot reach everyone. So had a little brainstorm, and this last February we started what's called ECOS. ECOS is Electric Culture of Safety, and it's a group of folks that are coming together and they're giving back. They're sharing freely. There is absolutely no cost associated to ECOS whatsoever either. So we had Danny Rains come in February to do the second episode with electric system grounding. And then in April, we had Lido Wilkins come in from International Line Builders, and he talked about my shocking awakening. And then we had this last May, we had Billy Martin come in and talk about flip the safety dynamic, and he came in May. Wonderful. That was the 5th episode. I just got back from Idaho where we did the passion behind the idea. That was number 6 episode with Caleb Thompson and Brady Hansen out of Idaho at Timpson Training Systems and Written in Red. Great video. That video will be ready for all ECOS memberships in about another week or so. And all the memberships, all you got to do is if you check out this flyer, all you got to do is to get registered to this to receive this free benefit, which this is actually part of what we're doing here as a supplement. All you got to do is type Bierer, capital B-I-E-R-E-R, capitalize all the letters to 22828, and then put in just a real quick information. It's real easy to do, and you're automatically a member. You'll receive ECOS announcements. You'll receive all the live line links, like for instance for today, and then you'll also receive the folks that are going to be coming up in a month or so, and then we remind about a week beforehand, and then you'll receive who's coming over the next couple of months. So you can pick and choose and make these your safety meetings. You could take the webinars, the recorded webinars, and you can use them for your safety archives, no cost at all associated, once more. So it's a great opportunity to get involved with safety, spread the word, and let's help our linemen, our heroes of power. Let's help them come home safely, all right? So that's what we're doing here. So you can get on, it's really cool. We got Mr. Rod Courtney coming in July, and he'll be here July the 12th at 9 a.m. and he'll be talking about the 8 habits of a highly effective safety culture. And then we'll have Jimmy Vaughn. He's going to be in August the 16th at 9 a.m. And he's going to talk about OSHA and how you are to be testing your grounds and taking care of that, and how the employer is responsible. So he's going to be talking a lot about detail, a lot of deep details as far as that goes, which is going to be really cool. We're real excited about that. But anyways, what we're going to do is we're going to talk about what we do, Bierer specializes in, and that is going to be presenting the lineman safety and tool training. So this is what we're going to start with. And what we're going to start with is we're going to start with our grounds tester. And it's important that you all test your grounds. There's still today a few utilities that do not electrically test their grounds, and it's important that you do. If you go to 1910.269 in OSHA regulations, you go to lowercase n, it talks about your TPGs, your temporary protective grounds. If you go down to number 4, then it starts talking about the IEEE 1048 F855 and how they are guidelines. The OSHA regs say that they're guidelines for the OSHA regs. So it's important to pick up these guidelines. I got a copy here, and it's important to pick them up from time to time and just check them out and read them, okay? But what we're going to do is we're going to talk about your TPGs. The TPGs, we're going to call these your best friend right here. These are going to be your best friend, okay? And you need to always take care of your best friend, and by doing so, you're going to be doing a visual inspection prior to use. So when you're out in the field, you're just going to do complete a visual inspection, and you're going to look for a lack of bubble jacket. You don't want to see any crimped cable or smashed cable. You don't want to see any blackened copper. If the copper is visible, you don't want to see blackened copper or patinaed copper. You don't want to see any cracks in your clamps, and you don't want to see any obvious loose components. And also what we're going to look for is a lack of oxidization on the components, especially on the contact points. Now, I've been to a lot of utilities, and everything that we're talking about as far as looking for a lack of, I have seen coast to coast, Brownsville, Texas, not that they were part of it, but into Canada, all right? I have seen all this. So, and it's amazing, if you're seeing it, then that means that the linemen weren't trained prior to our visit. They were not being trained to visually inspect at all. So it's important that you visually inspect. You make sure they look good. You also want to complete a mechanical inspection, and a mechanical inspection is going to be when you're grabbing a hold of those clamps and you're going to verify that you don't have any loose components. You're going to literally grab these clamps and you're going to try not to twist that clamp off the ferrule. Make sure the cable is tight in those crimps that it's on. Make sure it's nice and tight. So as long as it looks good and the mechanical inspection passes, typically these TPGs do well in electrical test, typically, all right? So what we're gonna do now is we're gonna go ahead and go through electrical test. So this is a number 2 cable. It's a little flimsy. I like 1/0 or 2/0 much better. But what we're gonna do is when you test, you wanna make sure that the cable is in parallel in your test. We recommend a 2x12 with some 2x4s on edge to build a channel, and it's gonna be pre-marked, pre-labeled as far as the distance. So you're going to measure it out, and you're going to pre-mark it. And then what we're going to do is, so when they're parallel like that, what happens is it keeps the cable from creating the magnetic field or impedance, and it also keeps it from having extra thermal activity as well. So you want to always test in a parallel. So that's what we're going to do. We're going to simply keep this in a parallel. Turn the tool on, and what we're going to do is down here we have a continuous current. So this tool places that true ASTM continuous current in an F855 on page 2, table 1. That's where you'll see the chart, and our chart basically mimics that as far as what's needed to test. And we're going to take our variac and we're going to crank this up to 165 amps. That's what's required for a number 2 cable. 165 amps. And you'll see, all right, we'll go a little higher, and we have a 0.23 voltage drop. So the chart here for this length requires a 0.24 or less. So this passes the test. And typically you're not going to want to test these out in the sun like we are here today. It's a nice warm, swampy South Carolina day. That's where our shop is. And you're not going to do this outside. You're going to do this in a controlled environment like under a cover. So it's not extra hot, which it is a little warm today. But the tool is very safe. We have continuous current flowing through it, but very little voltage, so it's safe. I can touch it, okay? So now what we're going to do is we're going to go ahead and put this in a coiled configuration, which when you're using your TPGs, you're never going to want to ever put these on a coiled configuration. Let's say you're using them and they're still on your reel on your line truck. You don't want to do that. You always want to take that TPG assembly and reel it out, put it on the ground, and you're going to make sure it's in close to a parallel situation. Or if you're using it, you're setting up your EPZ, you're going to want to make sure that you don't have any extra cable coiled up, maybe taped, and it's hanging in the bucket truck next to your leg. You don't want to do that, or hanging in the air coiled up. We were doing training last year for electrical contractor in North Carolina, and the guy said, hey, when we're working on that lower voltage transmission line, what we do with that extra length of cable is we coil it up and tape it. And you don't want to do that. You want to have it as straight as possible as far as A to B. And you can have some droopage, that's fine. So a little down in it, and that's fine, that's normal. But you don't want any coiled cable at all, ever, because it creates that magnetic field. So what we're going to do here is we're going to go up to 300 amps, and you see that amp meter right there. And you can feel this in your hand. All right, it's quite impressive. It's like fly fishing in a stream, and you feel that current flowing across your legs while you're fly fishing in that stream. You can feel the current just like that right here in your hands, but it's still safe. All right, Ryan, he's going to run a bottle through that center, and you can see that magnet in there, how it's interacting with that magnetic field. It's pretty amazing. Now we're going to keep the same. We're going to go ahead and get our parallel configuration, which negates that magnetic field. And you can see that that magnet is a lot less active and volatile. Okay, you guys see that? Big difference. Okay, so that's your TPGs. Always make sure that you take care of them. We're going to talk about two best friends. This is one of your best friends right here, is your temporary protected grounds. So take care of them and share with one another. Watch. You know, if you're working with your pole buddy or your bucket truck buddy, whatever you want to call your buddy, if you're working with them and you maybe visit his truck, you know, and go over the TPGs with them and what's necessary. It's important. Okay, Ryan.
All right. So next we're going to start talking about our voltage detectors, voltage indicators, phasing tools. Regardless of manufacturer, first thing you want to do when operating anybody's voltage detectors, again, voltage indicators, is you want to perform a battery test. So a battery test, no matter whose tools you're using, regardless of the manufacturer, that's simply all you're testing is the internal battery, whatever type of power source. Our tools have a 9-volt battery inside. And if you think about it, when you perform a battery test, there's no transformer stepping up that 9-volt battery that we've got to high voltage to give yourself what you would consider a true tool test on a live voltage source, a higher voltage source. So real quick, I'll just go through an example of what you should expect from a battery test. On a horn and light device, an audible visual device, you want to hear the horn and see the light. You want to get both indications. So real quick, a lot of our tools have a test position. I'll flip to that test position on the back. And again, you want to hear the horn and see the light. If you're not hearing and seeing both indications, you want to get the tool tagged, get it out of service, and get it sent back to the manufacturer, whoever it may be. If it's our tools, no matter the age, we'll repair them for a fraction of the cost of a new unit. So it's important to keep that in mind if you do have our device. For an analog tool, similar, some of the tools have a test position, others you'll just flip and hold to a spring-loaded setting. You want to see the needle deflect If you're not getting a strong deflection or you're getting no deflection at all, same thing. You want to get a new battery in the tool. All of our tools have a live line tool fitting on the front for the adapters to connect them to a hot stick, extendo stick, whatever it may be. That's where the 9-volt battery's at. When you put a new battery in the tool, you want to retest. If you're still not getting a strong deflection of the needle or no deflection at all, you may want to get the tool tagged, get it out of service, and again, get it sent back to the manufacturer. For a digital tool, similar, you either have a test position on the back or a spring-loaded switch. We're going to flip and hold here. So this tool's reading 7.4 volts in the battery test position. For our tools in particular, we recommend using them above 7 volts. If they're below 7 volts, we recommend putting a new battery in the tool. They'll still work down to below 6 volts, but they're going to be more accurate, give you better information with a good battery. So that's pretty much it for a battery test. Again, you want to keep in mind that's not a true tool test. You want to use it on a live known voltage source, and Brent will go into more depth about that here in just a minute. But next thing I want to talk about is tool functionality. For it, again, regardless of manufacturer, no matter who you've got, they're voltage indicators, voltage detectors, whether they're corded or wireless, doesn't matter. How they all work is they're going to make contact with a conductor. You always want to use a tool that's going to make direct contact. That way you know that particular conductor you're working on, the information it's going to give you is going to be for that particular conductor. So once you make contact with a conductor, the components inside the tool are going to look at that current. They're going to couple with the capacitance that you're working with, and it's going to give you a voltage indication based off of the current in relation to ground. So what I mean by that is, since this tool doesn't have a direct correlation to ground through a cord, it has to couple to the ground wirelessly. So if you think about it, what we can do as a manufacturer is we can add voltage settings on the back to where you're telling the tool how far from the ground you're working. So we've got URD, OH, and OHT. URD is going to stand for underground residential distribution, OH for overhead, and OHT for overhead transmission. Anytime you're using the tool in close proximity to a ground plane, whether it's the ground itself or a grounded structure, this tool, since you guys now know how the tools work, that couple with capacitance in relation to ground, is you may realize that since you're close to a grounded structure rather than the ground plane itself, is you may want to use the tool in URD, even if you're overhead and you're working close to a tower, close to a ground wire, neutral, as things as such. Once you get good using these tools, the wireless especially, you'll understand a little more about how the tool couples with that capacitance in relation to ground. But real quick, we'll go over some of the safety that's incorporated in the tools. So what we do that's kind of unique to our devices is we had this probe that extends out from the meter housing. Again, because these conductive components in here are what makes everybody's tools work, we add this extra distance to get away from the capacitance you're working nearby, and or the potential ground plane. So in this probe, what we do is we encapsulate resistors. Those resistors step down that current. We have about 25 million ohms of resistance in the probe. And we encapsulate those in an epoxy. That epoxy is going to keep out any type of water, dirt, grime, to keep and limit from an internal flash to those conductive components. So since this probe is insulated, you can't get any water, dirt, grime. What you're going to want to also do is keep the probe itself clean. How you would do that is just by using your regular hot stick wipe. You're going to wipe down the tool, keep it clean from any dirt, grease, grime, any type of calibration stickers, anything that could cause a potential track down the outside of this tool, same as you would your hot stick. So also we'll go into our line limiting mark. So ASTM F1796. If you go down to 3.1-9, there's a line limiting mark. It's a recommendation by ASTM for voltage detector manufacturers. Put a line limiting mark on the device in a distinctive location or mark to indicate to the user a physical limit to where the detector may be inserted between live components or touch them. So that's going to be here below the line limiting mark. We put it down about 2.5 inches from the end of the probe tip. And what that's going to be is a recommendation of where you're not going to want to pass with a potential or a potential ground. The reason for that again is because everybody's tools, we've already talked about, have conductive components inside that make the tool work. So if you were to get this meter head nearby a potential ground or a hot phase while you're making contact down here at the probe, these conductive components could have essentially caused a path across those two components. It would be an external flash. It's not going to hurt the tool at all, but it just creates an unsafe working habit, and we don't want to do that. With that line limiting mark, you're going to want to think of it as a radius around the outside of the tool of where you want to keep any type of hot phase or a ground potential away from these devices. Other than that, we'll go ahead and let Brent get started.
So folks, what we do is when we travel around the United States with this 40-foot trailer, what we backfeed like we're doing right now, these pad mounts, we backfeed them with 12208, come out the live front 19.9/34.5. We've got capacitive test points on some of our elbows, and we have a 12208 panel that we use, and then we have an overhead line. We'll just call this 7200. So what we have right here, it's actually 12208, but 7200 sounds a little bit better, so that's what we're going to say. Now it is a little warm today, so I think we're supposed to get up to 100. So when I'm walking around and Ryan's walking around, if you start hearing splashing, don't be concerned, okay? It's okay. But anyways, so if you have any questions in the future, you want to get on ECOS, you want to help not sponsor, but just affirm the cause that we're doing here and the safety, just contact me at safetytraining@bieremeters.com, and I'll get you all set up as well. So what we want to talk about is these meters here. Typically when a lineman is handed, line worker is handed voltage indicator, phasing tools, wireless or corded, typically in this training you must understand it's regardless of manufacturer. It doesn't matter whose tools you use. This is what this training is about. So typically the linemen, line workers are handed these tools and they go to work. That's it, done. There is no training, there's no explanation on how the meters function, but that's what we're going to talk about. We're going to talk about functionality and how these tools work. So how they work is they're going to make contact with the conductor, and that's going to be your X. Whether the conductor is energized or de-energized, that's always going to be your X right there. So they make contact with the conductor, plus Y. Plus Y is the tool itself couples with the capacitance when it makes contact with that conductor, and the tools look at that current in relation to the ground plane right here, the ground plane. So always remember that. If it's a corded device, the tool's looking at that current in relation to the ground plane through the cord. So basically it works the same thing, the same way, corded or wireless. It's looking at the current in relation to the ground plane. So if that's how the tools function, and then they look at that current and the tool gives you a voltage indication or a voltage reading up on the screen, whether it's an analog, horn and light, or a digital meter, it's going to give you that voltage indication. So it's got to be energized. The tools must be energized in order to do so. So X plus Y is the tool functionality, conductor tool functionality equals. First thing you always got to remember, equals, is safety. That's it. Always think of the safety part first before you think of and that voltage, information gathering. Always look at it like that. So the conductor plus tool functionality equals safety and proper information gathering. Okay? That's what the tool functionality, that is the equation from here on out. You all need to know that every one of you all are very important. You have a lot of significant and great purpose, and you're going to influence a lot of folks. And most of that influence is not necessarily through the words you say, but it's going to be through your actions, how you perform out in the field. You have a lot of apprentices coming up, younger folks, and they need that leadership coming from you through your actions. All right? So let's focus on that. So when you're using these tools, you're out in the field, you're going to have your PPE on, and I just want to thank Liveline Safety out of Texas, livelinesafety.com. Anyways, for supplying us with some leathers. These aren't the new ones. The new ones were too short. So Ruben, get me some longer ones. I need 16s. These are 14s. So anyways, got us some new rubbers. And so I appreciate that. A little investing his company has done. That's great to the cause, right? So you got your PPE on, and typically a lineman, when he's out in the field, they're going to use these tools, and you always got to remember that tool equation functionality: X plus Y equals safety and accurate information gathering. So the lineman's going to be back on his hot stick minimum 31 inches because of arc flash measurements. You're going to be minimum 31 inches back on your hot stick, and we recommend 36. I like 36 better. And the reason why is because the X, the conductor, plus Y, tool functionality, needs to stay that way, and that always equals safety and proper information gathering. What happens if you do what we call short stick? And if you do not, as a lineman, you do not want the nickname short stick. You do not want a short stick. What happens when you short stick is you negate two things. You negate safety and you negate accurate information gathering, because now the equation is X plus Y plus you. You're in the equation plus you. Because remember, the tools are looking at that current in relation to the ground plane. Well, you are potential ground planes. You guys are from the ground. Your body that you're borrowing for a short time is from the ground. So you do not want the tool to look at you. So that's not safe, and that's not accurate information gathering. So we want to be back. Here's what we do when you create. You're creating this air dielectric right here, this air gap. And that air gap is going to be your second best friend. All right, two best friends: temporary protected grounds and your air dielectric, your second best friend, and another best friend. I was doing some training in Florida a few years ago, and the linemen every single day would drive out of their service center, and they were looking at this big giant sign, and that big giant sign said that your best friends are your gloves and your temporary protective grounds. And I told those guys they need to take that sign down and change it. Your best friend is your air dielectric and your TPGs. All right? Gloves are a good friend. We're going to talk about some incidences that have taken place because folks trusted in their gloves and kicked their air dielectric, their best friend, to the curb. Okay? So you do not want to short stick. Also, another deal that we call is tool gloving. If you're a line worker, you do not want to have the nickname tool glover. All right? You just don't want to ever do this. Put the tools, your device, testing equipment in your gloved hands. I was doing training in California, and this one guy, about a 20-year journeyman lineman, walked up to me after the training. And I hear a lot of after the training words. A lot, okay? Unsaid, these incidences are hidden and unsaid. But ECOS, Electric Culture of Safety, we want to talk about it. We want to talk about it so other folks learn, so it's not repeated. And that's what we do. So what he did is he had a horn and light, and he went up to a capacitive test point barehanded. Only time he's ever done that, one time, but it only takes that one incident where you've learned something. But we need to learn it without having the incident. So he, for whatever reason, in his head, you know how guys are, in his head, he decided to use his test equipment without his gloves on, went to the capacitive test point. He got hit with about 200, 300 volts. Okay? That's what happened. Because remember, the tools are energized. So if the tool's energized, why would you do this? You got that tool's looking at that current in relation to the ground plane. The components inside the housing, they are energized. They're conductive. They're energized. So when you do something like that, it goes straight to ground, the lineman. Okay? So you don't want a tool glove. Stay away from the tool. Don't be part of the equation of how your tool functions. All right? So what we're going to do is we're going to go over some testing here. We're backfeeding these pad mounts, and we're going to go to capacitive test points, and we're going to go to these hot bushings right here. And this tool here has a P setting, VD1000P. So it has a proximity setting. So we use this tool. We could hang this tool out the line, hold it in our hand, and drive down the line in the truck. And we could find some bad spots here and there in the P setting. It's very sensitive. But we're going to use it, say we got storm, say it's dark outside, and we're not sure where that conductor is exactly, got a lot of bushes around, can't see very well. So we'll put it in a P setting to navigate through those shrubberies, navigate through the darkness, you might say. And then what we're going to do is we're just going to simply approach. You see the P setting. We're simply going to approach our capacitive test points. If you don't have capacitive test points, you can put the tool in the P setting and go to the base of the elbow, and there is that semicon material that this tool will sniff out. So let's show you. You guys see those numbers there moving? All right, let's go to the base of the elbow. It's not contact. Go to the base of the elbow. Okay, that's all you got to do, just to verify it's energized. We're going to call these hot bushes, we're going to call this a overhead line, 19.9. We're going to call it an overhead line. And we're going to approach that overhead line from the ground. And you don't have to have your gloves on in the P setting from the ground approaching that overhead line, but we're going to approach that overhead line. And you can see those numbers. Now, what we're going to talk about, so the P setting is very effective, but linemen don't want to use that tool to verify it hot or not, the P setting, the proximity. If you have any tools, any devices that are non-contact, we highly recommend that you throw them away. In South Carolina, we say chunk them or chunk it. All right? That means throw it away. And the reason why is because we want to, if we're verifying as 19.10.22.22, it's going to ask you to verify prior to putting on your TPGs. It's going to ask you to verify that you have an absence of your nominal voltage. But how we like to train is we want tools accurate enough that we're going to make direct contact. And that tool is going to give us the facts. If we have a lack of an absence of nominal voltage and induction, and we don't want to see any backfeed. That's what our tools are going to tell us. If you are using a non-contact tool, and let's say you're on an underbuild or you're in a substation, you're going to have a lot of influences. And those influences are going to affect those non-contact tools. And you're going to get readings 2 feet away, and you're not going to know if there's an absence of your nominal, for sure, an absence of backfeed, and an absence of induction. So always use direct contact tools. If you've got a safety guy, have him call me and we'll discuss it. All right? We have plenty of videos that prove and show what we're talking about. Go to YouTube, go to Bierer Meters safety training, pick a subject on YouTube. They're free. All right? So just go to them. So what we want to do is we want to have a tool that's direct contact. So we're going to verify direct contact on these capacitive test points if they're energized or not. And you can see now the numbers are not moving as before. They don't, and that's what you want. You don't want the tool to be affected and influenced by any conductor, energized conductor, until direct contact is actually made. And you can see there, it's saying we got just under 1,000 volts. Well, if you're working under 1,000 volts, this tool's not quite so accurate, but it'll let you know direct contact if it's energized or not. And there you go. All right, so let's go to our overhead line. it's also important, let's make a note real quick. It's very, very important that when you're using your device, your phasing tool, voltage indicator, wireless, corded, that you're always going to use the proper accessory. You're going to use a straight probe, hook probe, you're going to use a bushing adapter, and the reason why is because you don't want to take the shortcut and not use it, because the opportunity to bypass that line limit that Ryan was talking about is much greater, and that's a shortcut. Always use the proper accessory. And I know a lot of guys, they might lose their straight probe, they might lose their hook probes, and before you know it, they're not using it, or they just forget about it, or they get used in their mind, they just don't even think about the safety aspect. But you always want to use the proper accessory on the end of your cone tip or your device, regardless of manufacturer, okay? All right, so we've got this tool in URD, even though we're gonna be on this overhead line, okay? And the reason why we're doing that is because we're close to the ground plane. So remember how these tools work. They look at the current, the functionality, they look at the current in relation to the ground plane. We're the only manufacturer that discriminates in their tools, their settings, whether you're close to the ground plane, URD, or far from the ground plane, overhead, OH. Or this happens to work transmission as well, so we got to switch OHT. You guys see that? Okay, so we're going to put it underground, and we're going to go direct contact. Direct contact, and you see those numbers are not moving. That is a little bit, but not like before. Direct contact. All right, and we've got about 20,000 volts. Pretty accurate tool, pretty accurate. Underground, close to the ground plane. Let's put it in OH, overhead. So if you use any of our tools in the wrong position, the tools give you an inaccurate reading. It doesn't hurt the tool. So for instance, overhead, now we're reading 27,000 volts, but we know that's a 19.9, closer to 20,000 volts. So that's inaccurate. So the tool's telling us that one, either the tool needs calibration, right? Because we're using it on a live known voltage source, or two, we got it in the wrong position, that's the case, okay? Put it back in URD, underground residential distribution, and we make contact. There we go, accurate, okay? Now, we're trained regularly that we need to open test ground, all right? That's how we're trained. When we travel, how we like to train it, and this is how we believe that it should be changed. We want to do a test first before we open the switch. And the reason why we do a test first before we open the switch, a couple reasons. Here they are. One is we want to verify that the tool's working properly on the live known voltage source, all right? So that's why we don't open the switch first. Number two, and we'll talk more about this at the back end of this training in detail about what's going on. Number two is we want to verify that our head is in the game. Not only our head, but we want to verify that our partner's head is in the game with us out in the field, okay? It's called mutual accountability, and we're going to talk a lot about mutual accountability. And so we need to be mutual accountable one to another. Watch out for one for another, and we're going to talk about that at the end more. All right? So we're going to test the tool and make sure our head's in the game. Yeah, we got the cones out. We did our walkabout, and we came back and compared notes. Any concerns, trips, hazards, risks, all that. We got the traffic all set up, coned out, we're safe, all right? All of our markings are out. But the thing that we miss, and we're not talk about, and it needs to be on that sheet that we sign at the job site, the job briefing, the tailgate, whatever you guys call it. We need to make sure that we sign that on the sheet, that we have mutual accountability. This is so important. That needs to be added to those job briefings. You're gonna sign it. You have mutual accountability, all right? Needs to be added, because we're not adding that. We're not talking about it. And that's the biggest reason why guys are getting hurt alone, that fact alone, okay? The second thing is, so we test, and then we're gonna open. we're gonna complete and confirm a visual open air gap. All right, lockout, tag out. We're gonna have that in place. Next thing we're gonna do is we're gonna take our meter and test. So let's do that. So we got a confirmed open air gap. So we come back on this overhead line and we just do a test real quick. And you can see the tool is telling us that we do not have any nominal voltage. Our system voltage is gone. The tool is accurate enough that we don't see any induction and we don't see any backfeed. We're always going to check an absence of all three. I think this in the OSHA regs need to be changed. I really do. It needs to be changed. Okay? So then what we're going to do, that's number 3. Then what we're going to do is we're going to test the tester. So you test the tester like a live dead live test. We have a 3 kV power supply and you simply test the tester. Okay? So we tested the tester, and the testers that have a little hard, you want a straight probe usually. There we go. All right, so we know the tester is working. We also have a newer product, and that's our handheld power supply. And a lot of utilities are going to this handheld power supply because it's a lot smaller and they're just adding it to their kits. There you go. Test the tester. All right. After test the tester, then you go ahead and set up your EPZ. You're going to put on your TPGs, temporary protected grounds. All right. 5 steps. That's how we're going to do this from now on. We've got test, open, test the tester, ground. All 5 steps from here on out. All right, guys? It's important. That's on every job site. You know, here's the thing. It takes a little longer to go through the process of getting the job completed. And this is what folks don't understand. You know, all of our service centers out there, you go to municipalities, electric cooperatives, investor-owned, contractors, everybody is hurting for somebody to add to their crew. So we got a supply demand that's way greater than the supply of qualified folks to work out in the field. So we can't get the job done. You know, instead of getting 13 jobs done a week, maybe we only get 12, but we really need that extra guy so we can start completing 13 projects a week or job sites a week. Tasks. And here's the thing, if you don't work safely and take your time and you work safely, what's going to happen is eventually someone gets hurt. So someone gets hurt. So now not only you're lacking that one more guy that you really need in your service center, but now you're lacking another guy because somebody got hurt. So maybe they're out for a few days. Maybe they're not going to ever come back. And that's what's happening. So now we're lacking 2 guys, not just 1 guy. So you got to take your time and just go through the process a little slower. And I know contractors, you know, they have something called production. You know, and I tell you what, people and your folks come way before production, flat out. Okay? I hear it, I see it. Flat out. Okay. So what we're going to do is, when you're using a voltage indicator and you're using it in a situation to where you're going to approach your work area, you got different equipment every day, different scenario every day, and you approach that equipment and you're going to visually inspect your equipment, where your body is going to be, right? Proper body position, improper body position, proper tool position, improper tool position, and you're going to visually inspect. And if you have a situation to where your meter is going to be in close proximity to a ground plane, you could have an arc flash. This is the call we get more than any other call of Bierer meters. Is they call us and they say, hey, using a quarter wireless, they say, hey, your tool's no good. We don't have confidence in your tool. We think we're going to go to somebody else. We're like, okay, that's fine. We got great sales, so that's cool. Whatever you guys want to do. What happened? So they tell us what happened, and sure enough, they're in a scenario to where they weren't trained. Think about it. The line worker was not trained to visually inspect a work area when they're using their device in relation to components near the device. Maybe a bleed wire, maybe off of an elbow. A bleed wire is close by, a concentric, or maybe the cabinet itself is close by. Maybe you're working in a substation, you're using a corded tool, and maybe if you make contact with the conductor, but there's a bus, an energized bus nearby. What do you think is going to happen? This is the calls we get. They send us the picture, and we get all these pictures. They have all this concern, and what we do is we say, hey, look, we're going to come to you. Keep the tool. You need to buy another one after we get done visiting. But we're going to come out and we're going to give you lineman safety and tool training because your guys never have gotten it. It should be mandatory. We hear this too. Folks tell us this should be mandatory training, what you're getting today. And they didn't receive it. They don't know how they work. So they had an arc flash, all right? This last February, I was on a way to a utility in Texas. And I got to Mississippi, the safety guy that we were going to do the training for the next day. The very next day, he calls me and said, hey, we had an arc flash using one of your tools. And I was like, man, missed me by one day. It wouldn't have happened if I would have showed up. Anyways, no one got hurt. So what you're going to do in that scenario is you're going to simply put on a 0 ohm extension on the end of that cone tip. And you can use up to 2 if you need them. So let's do that. 0 ohm extension. Okay. So you're going to put on the 0 ohm extension. And you're going to take that tool from an arc flash potential incident of arc flash. You're going to remove that device out from that potential arc flash. Okay? Now remember those numbers, they were about 20.8, 20,800 kV, 20,800 volts, I should say. Okay, let me turn power up, throw in the switch. And now we see close to 19.9. Isn't that amazing? Almost true RMS voltage out of wireless. That's pretty accurate, pretty good tool. But now it's more accurate. So 2 things have taken place with the 0 ohm extension. One is we are 2 things. We are what and what? Further from what? Further from the other what? We're further from the ground plane. Remember how the tools function. And remember how they function, coupled with capacitance. We're further from the source. You see 2 bushings. Maybe this is a 3-phase overhead. Maybe this is a 3-phase cabinet, real super tight. All right, maybe it's underbuild. Let's try to get that meter head out of the corona that might affect it. Who knows? So now it's more accurate. So it's a lot safer. You see how that does it? So you put it before the 0 ohm. Here's that bleed wire. Okay. After the 0 ohm, here's that bleed wire. So you take the tool out of that potential incident, arc flash, okay? All right, real simple. Now what we want to do is talk a little bit real quick about proper body position, proper tool position, all right? So we got a corner pole right here. That's a corner pole. So I get a call from a lead lineman from a cooperative in Illinois. And he tells me he's using our tool. He's an analog. And he tells me that our analog tool he's using, he's getting on 7200, he's getting 13,000 volts on 7200. So, and he says our tools are no good. They losing confidence. They had them for 5 or 6 years. And they're thinking about going with another manufacturer. So I just told him, I said, hey, look, I said, keep the tool. I think you're going to discover something, and I'm going to come out, fly out to you guys and do some lineman safety and tool training. And, you know, when he said he's getting 13,000 volts, I already know in my head the scenario, what's going on. So I get out there about a month later and do the training indoors. It was real cold outside, so we did the training indoors. I just flew out. We got outside, and he got in the bucket truck with that broke tool. And he's getting on that broke tool. He gets in that bucket truck. He's by the corner pole, same location as when I received the phone call. And he makes contact with that conductor, and he's getting about 7,400 volts. So the broke tool was miraculously healed. But you noticed when you're working with energized sources all around you, you need to treat that energized source as if it's your enemy. Always. You never ever work with an energized source, if possible at all, at your back. Why would you allow your enemy to sneak up on your back? All right? You're always going to put that enemy, that potential, at your front, if at all possible. That's where you're going to be. Notice how my stick is. I'm back on my stick. This is proper body position. The enemy's in the front of me. I've got air dielectric. I'm away from the tool. I got my best friend air dielectric. And I'm back away from the tool. Before the class, when he was getting 13,000 volts, he had his back to the corner pole, and he was short sticking. Improper body position. Right there. All right? So he had improper body position times 1 times 2. You all see that? This is super important. So when he called me and said he had 13,000 volts, I knew without a doubt he was a living, breathing phasing meter. Right up here. Living, breathing phasing meter. And he needed some lineman safety and tool training. That's been several years ago, and I haven't heard from that crew yet. Why? Because they know they got lineman safety and tool training, and they understand how their bodies react with this field, with what their job. All right? And we're going to show you some really cool clips here in just a moment. So get away from that meter head. Don't short stick. Another guy was using a horn and light. He was at a corner pole, and he was using that horn and light, and he was in the bucket truck. And here's his video he sent me. He touches, the switch is open. He showed me the switch is open. And the tool is telling him that conductor is energized, but the switch is open. So, and the tool's going off as if that conductor is energized. So if that was a corner pole, if that's a corner pole, I got the switch open. I'm short sticking. My back's to the enemy. I got improper body position. And that tool is telling me that conductor's energized. Question, is that conductor energized or not? Yep, the tool ain't lying, it's energized. Switch is open. That capacitance is flowing across his body, across his gloves, through the tool, the opposite direction to that conductor. Isn't that amazing? And the tool sees it. Improper body position. Gave him a quick lesson. That was years ago, Louisiana, and it was swampy there too. Like here, all right? Haven't heard from him since. So you gotta have proper body position. Your tool position. It's important that when you're using your tools, if you're on a vertical stack, you're gonna come in to that center long source. You're gonna come in at a perpendicular to the long source, as well as perpendicular to the upper source and the lower source. All right? Make sure you always do that. If it's a horizontal stack, it's the same thought process. You just got to turn your head sideways and you'll understand it. Okay? That's all. Make sure you're not using that meter next to ground potentials. Not only can you have a arc flash potential, but you can also skew the true readings. So get a zero ohm extension maybe sometimes and get that away from maybe that potential, that other hot phase, or the ground plane. And keep it away from yourself. So when Ryan was talking to you guys about that line limit, what you want to do in your imagination is you want to create a sphere. And that sphere, you want to take that line limit and create a sphere around the tool, imaginary sphere, all the way around the tool and over the top of the tool, a big ball, all right? And that's where you want to kind of keep the tool away from other potentials and away from other ground planes. Does that make sense? That's where the protection is in the tool, all right? Well, you got your air gap here around the tool this way, your air dielectric, your best friend, protecting the tool out here. Always remember that, okay? All right.
Now we're going to use our PD25. It's our corded phasing / voltage detector, voltage indicator. I'm going to use it and take some measurements across Brent's body and across his gloves when he's using the tool properly versus improperly. We're going to use, now it's our PD50. It's our corded voltage detector / phasing tool. I got a cord running to the second probe over here going to ground. And I'm going to use this tool in the 2 kV setting to take voltage readings across Brent's body when he's using a wireless tool properly versus improperly.
And the PD50 and the PD25 series meters, they give you true RMS voltage, very, very accurate. So this, what you're about to see, is truth. It's not theory. We're not talking about something that's hard to explain. You're going to see exactly when you all are out there working, doing some line work, and you're working hot, your bodies interact with your job. They interface with the potential to some measurable degree, even when you're safe. And that's the whole point.
All right. So working properly, he's back on his stick. He's over what we recommend, minimum of 24 inches. So we're only seeing about 5 volts on his foot. Go to his back. He's got about 125 volts. And then we'll go to his glove. And we see about 12 volts.
Okay.
So now he'll move in closer and he'll start encroaching on that limit. We put of 24 inches or whatever your minimum approach distance is. He's gonna get on the end of the stick closer to the tool.
Called short sticking?
Yeah, he's short sticking, using the tool improperly. And now let's look at that difference on his foot. So before we saw about 5 volts, now we see about 15, 16 on his back. See 340 volts, 343 volts. And on his glove, now we're seeing about 75 volts. So you see already there's a difference just from going to using the tool properly to now he's short sticking. And even more so, we'll get him now to do what we call tool gloving, almost holding the tool in his bare hand or in a gloved hand. So before, again, we started at 5 volts. Now we see right at 90 volts. Go to his back, and with him being damp here, should be quite a bit. See 880, 882 volts. And on his front glove, we see 205 volts. So you see there's a big difference from using the tool properly versus improperly, short sticking, tool gloving.
All right, so now we were doing training about 3 years ago in Georgia. And there were some higher ups, safety people in Georgia. And they had these super dielectric boots, these overshoes. And they said, hey, we bet if you put these overshoes on that those numbers won't be so high. And I made a deal with them. I said, hey, look, if those numbers are similar, then I get your boots. Is that fair? And I'll use them for the trainings from this point forward. Is that fair? And they made the deal with me. You might be able to tell. So let's put the boots on and try it again.
All right, so even with the overshoes, you're gonna do all scenarios, or you're gonna go back to?
Yeah, we'll go the first and then the last.
So before,
on the rubber, Ryan.
Before we were seeing about 5 volts. Now we see 5 or 6 volts. On his back, 167 volts. I think before it was about 140. On his glove, we see about 20 volts. So now getting in closer.
Short sticking?
Short stick. About 80 volts. On his back, even higher, 1100 volts. And on his glove, 240 volts. So similar on his foot and his glove, but on his back there, now that he's insulated down at his feet, his body's actually building up capacitance. His body's now a capacitor. With the insulating shoes, it can't discharge to ground, so that's why we actually saw a higher number there.
See, the point is, folks, that just because you wearing super dielectric, just because you got gloves on doesn't mean you're invincible. That you went to the ink shop and got a big S tattooed on your chest, like you're Superman. It doesn't mean anything like that. So we were doing training in Tennessee several years ago. 2 linemen came up to me and they said, hey man, we had this incident. And during this incident, 2 guys were out in the field working, and they were working a cabinet. And they went to the cabinet. One guy was working the elbows. They were working it hot, and they knew it was hot. And they went to that cabinet, and one guy's back on his stick. He's got his best friend, air dielectric. He's working safe. The other guy noticed the cabinet was loose from the foundation. So just remember, you all need a good foundation in your life. All right? That's so important. The other guy noticed the cabinet was loose from its foundation, and what happened is he walked over to that cabinet with his gloves on and put his gloved hand on that cabinet. And when he put his gloved hand on that cabinet, he got arc flash right across his gloves. See how it works? Because this here is from ground, all right? This is from ground. And he crossed the red line. Now, when he crossed the red line, it was hot that day, sweaty, kind of like today, where you got swamp britches, okay? And so when it's hot, you're sweaty, things like that. Maybe it's misty outside, foggy. Sometimes you can see the little droplets in front of your face fall to the ground, just float in the air. That's an energized situation. And what happened is that red line came out to him a little more than normal that day. And he crossed that red line and found out about it. He spent some time in the hospital, but he didn't lose any digits, and he's fine today. But I tell you what, man, you guys got to keep your dielectrics and be smart about things, all right? Think about things. Don't just rush into it, okay? So what they did is they wrote up the incident report, and they said the reason why he got arc flash because in the cables in that can, there was rat piss, all right? So anyways, that's escape rat. It's not true. So let's see what happens. So you guys see I got gloves on. And you guys see these numbers. You guys see those numbers. I got gloves on. Watch what happens to these numbers as I approach with gloves on. What are they doing? They're going up. They're going up, aren't they? Okay? So that's what happens. Remember, it's energized. They're going up. So now it makes sense because you know how these tools work. So the idea behind that is when you're using these devices, corded or wireless, don't become part of the tool. Don't be that bigger bird on the line that's going to feel that uncomfortable charge. The little birds, they're okay because compared to the ground, they're small. But don't work with your devices, regardless of manufacturer, to where it becomes X plus Y plus U. Don't get in the equation, X plus Y plus U. You don't get accurate information, and you get an unsafe situation every single time, okay? Okay, Ryan, you want to show some real quick corded safety?
Yeah. So
let's phase over here.
Using our corded tool, since it's going to be accurate, like Brent said, it's going to give you true RMS voltage. What we're going to do is we're going to use it to phase on a capacitive test point. The capacitive test point is going to be a lower potential, and if you have the option to phase with that information, we recommend you do so just because there's less potential. It's a little bit safer work method, work practice. So the first thing we're going to do anytime we're phasing is we're going to go phase to ground, just as you would if you're inserting to an elbow or an overhead line. The reason we're going to do that is we're going to verify a couple things. We're going to verify that the tool's working properly on a live known voltage source, and the tool's letting us know that we need to get our head in the game. We need to be ready for the job at hand. So take our first reading, phase to ground, and you'll notice it's about 380 volts. So just like phasing overhead, you're looking at the difference of potential, or same potential, 0 is going to give you an in-phase reading. Here with elbows, each elbow from the manufacturer is going to cure different, so the resistance values in those capacitive test points is going to have a little bit different resistive value. So we get 380 on this first one. We go here.
right.
And we get 530.
So what, about 150?
Yeah, so we see a
140?
difference of about 150 volts. If we're in phase, we'll see that 150 or 140 volts. If we're out of phase, we'll see about a 1.72 multiplier of 500. It'll be real high, and we know then for sure we're out of phase. So we get Brent to go to that other capacitive test point. Maybe. And we see about 150 volts. So we know for sure, since it's the difference between those two values, that we're in phase.
Okay, let's go to that panel there, Ryan.
So we'll go to our secondary panel, 122.08.
Okay, you go ahead to the A.
Okay.
Okay, ready?
So we'll go phase to ground. We see about 119 volts. Phase to phase, it looks like we're in phase. We see 0 volts, maybe 1 volt. The reason we may see 1 volt instead of 0 is because of the bleed in this cable. As you see, we've got it laying on the ground here. Our cable, unlike other manufacturers, is shielded up to 30 kV. So it's safe to use laying on the ground, laying on a metal box. You can brush up against it, but you always want to treat the cord as energized. So here we go, phase to phase, out of phase. We see 205 volts.
Okay. Okay, let's go to this overhead line there, Ryan.
So throw on a bushing adapter real quick.
Now notice how when Ryan and I switch out our accessories, our tooling, when we switch out a device, we switch out equipment. What we're gonna do every single time is we're gonna take a few steps away from that job, from that equipment, that energized source. We're gonna take a few steps away, make the change, and then we're gonna re-engage. Yeah, it takes a few extra minutes, a few extra seconds to do it like this, but we're gonna do it like this every time. We're gonna walk away a little bit away, get away from that energized source. We're gonna make the switch, and then we're gonna re-engage.
So we've done capacitive test points, secondary, now we're going to primary voltage. Again, phase to ground, we're going to take that reading first for those same 2 reasons, to verify the tool's working and that our head's in the game. So you see we get a 1 on the screen. Like Brent said earlier, the tool's giving me a funky reading. So it's letting me know that it's in the wrong position. I've still got it in the 2 kV position from earlier on these secondary voltages. So I'm going to put it in the 25 kV setting or 50 kV setting for the PD50 and retest.
Go ahead up there.
And we see about 20.2 kV. So from earlier, the wireless tool was giving us right at 20 kV. So we see how using that tool properly, it actually gave us good information, just like a corded tool. So we get close to 0, you get about oh, it is 0 now. Sometimes with the cord laying on the ground again, you'll see a 0.1, not quite 0. So we see 0, so we know for sure these 2 bushings are in phase. Anytime you're using a corded tool to phase, what you're gonna do is you're gonna go with the second probe to ground first before you remove the tool. The reason for that is you want to discharge any of the built-up capacitance between the 2 probes. So as I take it off, you'll see that number go down slowly. The reason it goes down like that is because of the resistance in the probe. It takes a minute for all that to discharge. There's nothing wrong with the tool, it just takes an extra step.
Okay. Very good. All right, that's good, Ryan. So, Ryan, can you go ahead and de-energize us, and I'm gonna wrap this up.
All right.
With just a little more safety. Okay, Ryan's gonna de-energize the trailer. All right, we're good? So just a couple more things. You know, going around meeting with all these certified utility safety professionals around the country and speaking with them, and you know, going to the IP conferences, which I highly suggest if you're at all involved with safety that you get certified, CUSP, Certified Utility Safety Professional. The guys there, they're like family, and I tell you what, the guys are so serious, and that's who the speakers are that come and speak at ECOS. These guys are very serious, they're very passionate, and they got heart, man. They're in the right job, lots of experience, and unfortunately some of that experience had some negative consequences, but they're safety guys now. But here's the deal that we need to talk about, and that is on these job briefings, we need to talk about mutual accountability when we're on the job site, and we're not talking about it. There's so many things going on out there. You know, economy, people talking about fuel prices, and, you know, something going on in Ukraine, and, you know, everybody's getting all scared of some virus floating around. So there's a lot of things going on. And a lot of people have their ears in politics and their mind in the news, okay? But man, you guys got it, as linemen, you can't afford to have that space filled with these things. We got a job out there, it's one of the most dangerous jobs in the world. And we got a job to do, and those things that are in our minds, you guys got to deprogram and just get away from those thoughts and get away from these words that they keep speaking. Don't listen to them, all right? But what you guys got to think about is one another. You know, we keep saying we're our brothers, we're our sister's keeper, all right? We say that, we fist pump and we get all high-fiving and we get all excited about being our brother's keeper. But when we're on the job site, we got to have mutual accountability, and that needs to be on that job brief. Mutual accountability. Here's another thing. And usually if there's a lack of mutual accountability, the reason why is because there's a lack of personal accountability. That also needs to be on the job briefing. For instance, I've been around a lot of linemen. We go, you know, we do all these tools, we do all the field training, do all the safety training around the country. Thousands of linemen. And it's a great time and great guys. They're real. I love it. I wouldn't want to do nothing else at all. Couldn't imagine it. But check this out. I hear guys off to the side, earshot, right? I don't talk about it, but I hear guys talking about it. They brag about how they were all up all night drinking. And then they go to work. How if you're not drunk, there's no reason you can be setting a pole. I hear this stuff, all right? And the thing is we got to have personal accountability. In other words, if you know that you have a job to perform that day or the next day or a couple days later, there is no place in your body for any alcohol as far as getting drunk. And there is no place in your body for drugs, because if you lack personal accountability when you're on that job site, there is no mutual accountability, or very little of. Very little of. And this is a true fact, and I know it, and this is the biggest reason why line workers are getting hurt and there's incidences. The biggest reason is a lack of mutual and a lack of personal accountability. Period. All right? I see it, I hear it, and I know it's fact. You guys can have safety meetings until it's coming out your butt. All right? You got a big old gut. You know, you got what you call a food baby of safety. And you're like a sausage packing factory. You take safety and safety comes out your butt, all right? You can have so much safety, but that's not gonna do you any good unless you have personal accountability, which flies into that day's work, the next day's job, mutual accountability. So two guys were working, they were changing out a pole several years ago in Michigan. And they knew it was energized. The pole was broke and they were changing it out. One guy was working the boom. The boom hits that energized source. At the same time, his buddy, his friend, was in the truck pulling out some gear. And in a split second, his buddy was aground for that energized source, because that energized source wants to go home bad. And if you give it that opportunity, it's gonna not ask first, it's just gonna go. And it's so fast, there's no time to think, nothing. And so that 20-year journeyman lineman, several years, he's gone. His wife lost her husband, the kids, no more dad, just gone. They get the call, man. Think about it, they get the call. Crazy. Several years ago, 2 guys are working. One guy's in a bucket. He's trying to get up to that energized source. The bucket gets caught on the lower communication cable. Gets stuck. So he's going to be the man. He's going to be the Tarzan, and he's going to get out of that. So he's working the hydraulics, building up some pressure. So he builds up the pressure, works up the hydraulics, just enough to where he does get out of that situation, that stuck situation, and that pressure that's built up in the hoses flies him up just high enough to where his arm touches that first energized source. Boom, arm gone. So the question is, did those guys, his partner was in the truck shuffling, papers or whatever. He's in the truck. He's not watching the guy in the bucket. The guy in the bucket is not verifying the guy that's outside, his buddy, his partner, was not watching him. The other guy, when they were changing the broke pole, he's in the truck getting some gear. The other guy working the boom, he's not watching where his buddy was. The guy in the truck wasn't watching where the boom was, his buddy with the boom. So one fatality, one guy loses the arm. All right, so the question is, was there mutual accountability at that job site? Both of those job sites, was there mutual accountability one to another? And it's both ways, guys. When the incident happens to the person, it's also because the person the incident happened to did not have mutual accountability to the person that should have been watching, and vice versa. And what do you think happened the night before? Huh? Was there personal accountability the night before, the day before? We don't know. But that needs to be on the job briefing as well, both those things, personal and mutual accountability, and it needs to be signed. All right, guys? So let's be safe. And if you're truly going to be your brothers and sisters' keeper, it's time to speak up. When you're at a job site and you see something that's funky, rank does not matter. Longevity does not matter. Speaking up matters. You speak up. And that's what Lido Wilkins talked about. Speak up. Billy Martin talked about connecting with one another. And these are both episodes you guys can have at no cost. They're free. All right, just contact us. Get on ECOS. This is what we're doing, and we need to make a change. We need to have an electric culture of safety, and we got to work together, equal for safety, for our heroes of power. Okay, guys? Be safe. Thank you so much.